So it is an on policy temporal difference learning. Just remember the term on policy, where you follow the same policy pi for choosing actions in both the present state and the next state. Understand with an example. Assume this is my environment and I am at a block 900 and 900. 900 is basically this point, right? As you can follow with my cursor. Now assume that I am following SARSA approach and I am considering epsilon greedy policy, right? Now when I am considering epsilon greedy policy, I can take a random action if the random value is generated below 0.5. As I take a greedy action. Now 0.5 is something that I'm setting up, but you can take the set of epsilon as anything. So I choose to move left. I'm at currently this state. I took an action left on this particular state and I moved to this one 700 900 coordinates and get a reward R. Now to update value function for state 900 900, this particular cell, uh, what function I would be using? I would be using this value function 900 900 comma left, because this is the state and this is the value, this is the action that I've taken, is equals to value function 900 comma 900 comma left plus alpha, reward is the reward that I'm getting, plus discount factor, value function 700 comma 900, this is the future state that I'm coming to, comma up. How up is coming? Because as I told you, I'm following epsilon greedy policy. So assume that next time when I'm choosing the action for the future state, I got a random, I got a epsilon less than 0.5 and I'm going with a random action. And the random action chosen is up now. So as you can see that up is not the best approach to follow because there is a blocker here. Hence, you might be negatively rewarded for that. Minus value function 900 comma 900 comma left. So here you can see that how SARSA is implemented. So basically in temporal difference, if you see that this is the point that I wish to reach, was my starting state 0 0, and this was my final state that I wish to reach. But now, and I am currently at this particular state 900 900. When I'm taking an action left, so updating the value function for state 900 900 comma left, what I'm doing is that following the particular equation that I've mentioned earlier, where where I'm choosing the action for the current state using epsilon greedy, and for the future state also I'm following the epsilon greedy approach only. So when following epsilon greedy, I got a left. I got an indication that I should move to left. And but when I'm went to the future state 700 comma 900, the best approach would might have been to move right again, or move up down, or move left. But in this case we got an up because it is following an epsilon greedy approach. So in an epsilon greedy you can get a random value for the action as well, which is getting represented in this, and hence we are not taking the best possible action to be taken but a random action depending upon the epsilon greedy approach. This is what SARSA does.